We've arrived at the chapter where we start to run our tests. But before we do so, we need to make sure that the tests are able to run concurrently. If you're watching this, I assume you already have your tests written and set up this way, but here are a couple of requirements. Tests have to be 100% independent. This means that test B does not require test A to run first. And the driver cannot be shared. Each test needs to have its own instance of a driver, and anything dependent on the driver, like page classes in the page object model, must also follow this rule. A couple other things to note is that test results are reported to the machine with the Docker engine, or your main manager nodes. This is currently my laptop, so my test result.xml file or any screenshots or logs will be saved to my laptop. This obviously doesn't apply if you're running in a configuration where these are saved elsewhere, like an S3 bucket. But yeah. And lastly, I think it's helpful to label or name logs or files or even some directories with a unique hash or timestamp, just because you don't want anything to be overwriting each other since you're running tests at the same time. With that out of the way, let me introduce you to the example scenario that our test will be covering. The website is lolesports.com, but we'll be working on the standings page. To get to this page, go to lolesports.com, find the standings tab at the top and click on that, and then filter by any league that you want. By default, it's on the LCS league, but any league, clicking on that will then change the view and filter by those teams. After that, we'll be asserting that the first place team is correct. Now let's move into the code and see what we're working with. I'll show you a few classes so you have enough context on what this demo framework looks like and how it's going to run the tests, but you do not need to follow this exact structure for your tests to run on the containers. Honestly, the most important pieces are the remote WebDriver class and the URL we pass into it to connect the driver to the grid. So let's start with the driver factory class. DriverFactory.build requires a type of browser and the name of the browser. If the type of browser equals local, then I'll be running the tests on my laptop. If the type of browser is remote, then I'll be building a remote WebDriver. So here, build remote WebDriver is going to be calling this method underneath it. This method uses the remote WebDriver class, and that class requires that you pass in the URI to the Docker grid, and then also any other options you want to pass in, like start maximized. After picking whether we have a Chrome or Firefox driver, we then give driver that value and ultimately return that driver at the end of it. We're calling our driverFactory.build method whenever we initialize a new driver, and that's done in our test base class. This class has a setup method, which is run before every test, and a cleanup method, which is run after every test. Notice how we pass in a type and a browser. These values from the test context class come from a settings file called the .runSettings file. This runSettings file has a parameter list where you can give its values. The name here, browser, has the value of Chrome, and the name type has the value of local. Back in our test base class, you can then see that parameters type would return local or remote, and parameters browser would return Chrome or Firefox. By default, we are using a local Chrome driver, but we can easily change these values and have it affect all of the tests that use this test base. Lastly, let's take a look at our standings test suite. Each test is decorated with a parallelizable attribute, so that way we can run them concurrently. Also notice that each test has categories, so that way it's easy for us to filter which tests we want to run. Now I know what you guys are thinking. Enough talk, let's test. And I totally agree. So let's do this thing. I want to run my demo test locally first so you can see them actually running before running them on the grid. So let me open my terminal here and let's see if everything is down first. Cool. And now I'll run my tests. .NET test. I'm going to use that .run settings files that you guys saw earlier, and then finally filter with the test category equals a demo. That'll start running, and then we'll see two tests running concurrently. Awesome. 2 tests ran, 2 tests pass. Cool stuff. Now we'll run those tests remotely on the grid. So let me hide my terminal, go to .run settings, and change my type from local to remote and save it. Let's open up my terminal again. And if you guys remember, I actually don't have my grid up right now. So let's do that. Docker compose up-d. We'll spin it up. Awesome. And now we'll run that same command again for running those 2 tests. Now again, we're not going to see the browsers open up anymore because they're running remotely on the grid. Whoops, it looks like one of the tests failed. Let's check it out here. It says click on LEC league filter, and it looks like that did not work when trying to switch to that league. If we open up the directory here, then we'll actually see a failed to click LEC image. Notice how even though it ran on a container on the grid, it still saved the screenshot on my machine. If we zoom in, we'll see that the left-hand menu to actually filter by league doesn't exist, which is why the element is not interactable. Looks like you would have to filter by clicking on this to reveal a drop-down and then click on the filter you'd want after that. Good catch, test. We've now ran 2 tests on our Selenium Grid, so round of applause to you guys because up to this point you've now learned Docker, you've learned Docker Compose, you're spinning up containers using images, and now spinning up a whole grid and running your tests on it. So that's pretty amazing. However, the name of this course isn't spin up 2 containers, run 2 tests, and feel good about yourself. The name of this course is Scaling Tests with Docker, aka I want you guys to be able to run as many containers as possible at the same time. I mean, if you have 100 tests, you run 100 tests at the same time. If you have 1,000 tests, you run 1,000 tests at the same time. And so that's what we're going to finish this chapter with, is learning how to scale using everything that we already know. So the first thing I'm going to do is in the terminal, let's check to see where I'm at. Looks like I still have that up, so let's bring it down. And there we go. Going to clear this so we have a nice clean slate. And now we're going to say docker compose up-d. And you guys, this is the magic right here. If I were to not do anything right now and ask you guys what you think at home this is going to be doing, I'm sure you'd get it right. Essentially, I'm saying use this Docker Compose file, spin that up, but I want you to scale the number of Chrome containers to 10. If I hit enter here, it's going to take a little bit longer just because it's spinning up so many of them. But now if I were to say docker ps-a, we have quite a few more, quite a few more containers that we've spun up. To make this even more awesome, if we were to go to our grid here in the browser and hit enter, you guys, 10 containers in a matter of seconds, and all of these are ready to go. The crazy thing about this is you can basically pick whatever number you want to scale to. So, I mean, if you wanted to say scale Chrome 100, it would spin up 100 containers and you would have 200 browsers kind of just waiting for you. So let me go back and tear this down. Docker compose down. It's cleaning everything up for us. And yes, of course, if you did restart, it would restart everything for you. I have 9 tests. And so if I wanted to run 9 tests, I would need 10 browsers. And so now I'm going to spin everything back up. But this time, instead of scale 10, I just need 5. So I have 10 browsers. So spin this up now. And now I can just go back to running my tests. And I can run all of them now. So instead of just demo, I'll run all of my standings tests. And let's go. Beautiful, beautiful magic. So I hope you guys are as excited as I am about this because I love doing this day in and day out. And it gets even crazier when you start implementing this into your CI/CD pipelines because you can actually have all of this automatically done for you, the spinning up and everything. It gets pretty awesome. So that's out of the context of this course, unfortunately. But hopefully you guys can see how simple Docker and containers have made it to be able to spin up, restart, and tear down these entire grids, and I mean scaling to the size that you and your organization needs, and all of it within seconds. I know I say it over and over again, but I really want you guys to feel the impact of how powerful this stuff is. So now that we have come to the end of this chapter is all about scaling your tests. In the next one, we're going to be seeing that your computer can only handle so much. So even though I would love for you guys to be able to spin up 5,000 containers on your laptop, I can almost guarantee it won't be able to handle it. So what we need to do now is to scale our containers so then we can further scale the amount of tests we have against containers. And we'll do this with something called Docker Swarm.